Hi guys, I hope you all are doing well. So today we'll be starting with our chapter 6 of class 9 mathematics, that is measuring space, perimeter and area. In the last video, we have learned about our chapter circles, that was I am up and down and down and down. So we have studied all the concepts, theorems regarding the chapter circles. So today we will be starting with our chapter measuring space, perimeter and area. So we have to study perimeter and area of different shapes. Mostly we'll be having square, rectangle, circle, and quadrilateral. So let's get started. Uh, Firstly, what do we mean by perimeter and what do we mean by area? So basically, if I have a land with me, let's say it could be of any shape. Okay. So let's say I have a land of maybe like this. I have this much amount of land, right? So now, for problems or like for real life like situations, if I were to fence this piece of land, so basically, I want to fence it. So do you know the meaning? I hope you know the meaning of fencing. So basically, मुझे यहाँ पे fencing करना है. So I'll fence around this part of my land, right? Right. I'll just close all the sides of the land with the fencing. So basically, whatever I have drawn with yellow, that is that much amount of fencing I need to do. Okay, but I'll need barbed wires and I'll have to pay for fencing. And that fencing depends on the length of the perimeter of the sheet or the length. Say if the cost of barbed wire is one or is let's say 10 rupees, 10 rupees per um per meter, let's say per meter, right? So basically for 1 meter I need to pay 10 rupees. Okay. So I need to find out how much meters is this distance is, right? Is this difference, right? So this is where we need to find out the perimeter. So if we look at the definition of perimeter, perimeter is the total length around the border of any given shape. So basically that is the total length around the border. That is the total length around the border of any given shape. So basically, if I fence this area, I'll need the fencing is equal to the perimeter of the shape. So perimeter would be anything that we'll see later how to calculate the perimeter. I hope this is understood. So you can also take an example of a box, maybe if you want to gift wrap it. So how much paper do we need? So I'll just have to cover all the sides of the box and I need that much amount of paper. So that is the perimeter of a box, let's say. So yeah, I hope that is understood. So now we need to study perimeter of different shapes. Okay. So firstly we have square and rectangle. Okay, cool. So I'll just draw rectangle. I'll draw square. So you know that the sides of all the squares are equal. So let's say my side is equal to A, A, and A, right? So now if I were to calculate the perimeter of the set, so what I need to do is to sum all the length, right? So let's say this is my first side, this is second, this is third, and this is fourth. So basically, if I sum all of them, what I'll get, which the perimeter is equal to P. So I get A plus A plus A plus A. That is perimeter is equal to 4 times 3. So therefore, we get the formula of perimeter of square of any side A. Let's say A can be anything. It could be 1 feet, it could be 2 feet, it could be even 1 meter, 2 meters, anything. Therefore, this is the formula of perimeter of square. Okay. So basically, I need to add the squares, and a square has four sides. A square has four sides. All of the sides are equal. So therefore, the perimeter becomes four times the size. Okay. I think that is understood. Okay. Next up, we have a triangle, an equilateral triangle. You know that for an equilateral triangle, all the sides are equal. Just say A, and A. So for an equilateral triangle, now you know that all the sides are equal. So therefore, if we say perimeter is equal to all the summation of all the sides, that is P is equal to 3A. So this is the area, this is the perimeter for a triangle, or typically we can say that for an equilateral triangle. I hope that's understood. Okay, next up we have perimeter of, we don't have perimeter of rectangle over given in the textbook, but still we learn the perimeter of rectangle. If I say this is a rectangle, let's say its length is L and its breadth is B. Okay, cool. Now, as you know that opposite sides of the rectangle are equal. So if this side is L, so this side also would be L, and this side would be B. Okay. So now if I add them, let's say perimeter is P. First, second, third, fourth side. Okay. First side is L, second is B. Again, third side is L, then again B. So I get it as 2L plus 2B. In short, we can write it as P is equal to, I will take two common, L plus B. So this is the formula for perimeter of rectangle. I hope that is understood. Okay. Next up, we have perimeter of circle also. But we don't call it as perimeter of circle, we call it as circumference. Okay. उससे पहले we need to understand that the ratio of perimeter to the side for a square is 4 is to 1. If you take the ratio now for a square, let's say we have a square. Okay. We know that the side is A, okay, and the perimeter is 4A. For a square, the ratio of perimeter to side, that is 4A upon A, is, now if we cancel out A, then we get it as 4, that is 4 upon 1. So therefore the ratio is equal to 4 is to 1. That is what that is what is written in the textbook. Okay. I hope that is clear. And this is the fixed ratio. It is true for all the cases that you need not to worry. Okay. That would not need to worry. Okay. Now for equilateral triangles. Okay. Now we have equilateral triangle. For an equilateral triangle, our side is A and our perimeter is 3A. Okay. Now, now if we take the ratio of perimeter to the side, we get A upon A. If we cancel out A, we get it as 3 to 1. So therefore, ratio is written as 3 to 1. I hope that's clear. So this is how we find out the perimeter of all the shapes. Next up, we have circle. For circle, we are concerned with for circle. We do not call it as perimeter. We see it as circumference. So basically, this is our circumference. ठीक है. तो ये जो इतना पार्ट है जिसको हम perimeter कहते हैं, that is the circumference for a circle. ठीक है. But what is the formula for circumference of circle? So firstly, we need to understand what is pi. So pi is a very unique number, or a rational number, or we can say that it is a very p by q form of expression that is very unique in nature, and that has a fixed value and that goes up to infinity. So basically, you just need to remember whatever the theory or the history is given in the textbook, that you need to do it on your own. You may read it and you will understand what is the concept behind it. There is no concept behind it. It is just they have given many real life scenarios that happened in the past that made the story of pi. So basically, pi is the number that is denoted as pi is equal to 22 by 7. If you divide 22 by 7, you will never get 10 answers. It is it you neither get a recurring number nor a non-recurring number. It is continuous number, that is 3.14 1592 3.1428 per pi, 3.1428. So basically this is what we use, and this goes up till infinity. Okay, it has many numbers, but mostly we need to just learn as per the question given in the question. We need to learn 22 by 7 or 3.14. Any of the one we need to use. So just remember that this is pi is equal to 3.14 or 22 by 7. So then what is the circumference of, and also we need to remember that the pi is a rational number. Okay. Okay. Now next up we need to learn that then what is the length or the circumference of the circle. So basically circumference of a circle is given as, for a circle of radius r and diameter d, the circumference is given as pi 2 pi r. Firstly, it is given as pi d. Now we know that the diameter is equal to the two times radius, right? Because this is also radius, this is also radius. So radius. So diameter is equal to two times radius. Okay, so if you substitute this value into this equation, we get circumference is equal to 2 pi r. So we can use any of the two formulas to solve our questions, and therefore we'll get an answer. So that is the length of an arc of a circle. So basically, we saw in the last video that what is arc. So this is okay. So now we know that two semicircles make a full circle, right? We can see over here that this is one circle and this is another semicircle. So basically, two semicircles make a circle. So if we were to find the length of one semicircle, or the arc, maybe if we were to say, then just we need to divide the circumference by two. So if we divide this by two, what do we get? 2 pi r upon 2 is equal to pi r, or also we can say it as pi d by 2, because as you know, for two semicircles, like if I divide this, for for these two semicircles, our circumference is this. So for one semicircle, it would be just we need to divide it by two. So this is how we get. And for a quarter circle is basically if we divide the circle into four parts. So this is one quarter. If the color is visible, this is one quarter. So four quarters make a circle. So this circle, for this we need to divide the circumference by four, right? I hope that is understood. Okay. Two notes that we need to take care about is the formula for the length of semicircle may also written as 2 pi r into 180 degree upon 360 degree, because we can see that gets cancel this gets cancelled out. Okay, and also the formula for the length of quarter circle may also be written as 2 pi r into 90 upon 360 degree. Again, the same formula, because this will get cancelled out. That will be 4, so 2 pi r by 4. Here also it becomes 2 pi r by 2. Okay, I hope that is understood. If the arc is ED and it subtends an angle of theta at the center O of the circle, then the length of the arc is 2 pi r into theta upon 360 degree. This is also a formula that you need to understand. You can, for this case, you know that is a semicircle. Okay, if I draw a semicircle, we know that the angle is 180 degrees. So therefore, just substitute this part into this formula. You'll get the same expression as this. I hope that is understood. Okay. Next up, you have much theory in this chapter, but that is okay. You can read it on your own. I'll not cover that theory in this chapter, and also the proof. I'm not going to cover it. I hope you understand it. Okay. So moving further, we have problems exercise. Okay, that you can do it on your own. You just need to find perimeter, etc., etc. That is okay. ठीक है. Next up we have area of rectangle. ठीक है. Now we need to find area of rectangle. Now what is area? So basically area is a value that is enclosed by a figure. Now basically if I have a land that is in the form of rectangle, I want to do farming on that land. So basically I use all of this land. No, the space enclosed by a figure can be called as area. So this whole part is called as area. So this is our area. Now we know that our sides were L and length was B, right? So the formula for area of rectangle becomes L into B, that is length into breadth. We multiply the side and the square, we get this whole part, that is the area of the rectangle. I hope that's clear. Now, if I have a square, let's see this, that is of side A, that is of side A. So to find out the area of square, the formula is given as A square directly, the square of the side, because you can just multiply both this side because they are same A into A, it becomes A square. I hope that is clear. Okay. Next up we have area of parallelogram. Okay, what is you have also seen the formula for parallelogram in standard 8. Again, we need to see it in this standard also. So basically, it is given as base into height. Whatever the parallelogram is, uh, whatever parallelogram is, its formula for area is base into height. So you just need to find out the base, find out the height, and then you can just multiply it and you get the area of the parallelogram. Okay. Next up, we have area of rectangle. Now, this is true for any type of rectangle, isosceles, scalene, or equilateral triangle. Let's say we have a triangle. Oops, we have a triangle. Okay. So for this triangle, I have a side, right? I have a side, let's say A. Then I would have, if I draw a perpendicular bisector, I'll get a height and I'll also have the base. Okay. So the area of perimeter, sorry, the area of rectangle is given as half into base into height. I'll not cover the proof for the same. You can do it on your, you can do it on your own from the textbook. Okay, cool. Next up, we are done with area. Also, we need to focus on the property of median of triangle. We can see that a median is the line segment joining a vertex of the triangle to the midpoint of the opposite side. So this is the median. Okay. This is on the height. Okay. But this is the median. Um, you can see that this is the base and this is the height and the line that joins the center of a that joins the vertex of a triangle with the midpoint of the opposite side of the triangle. So this is the midpoint of this triangle, right? So that is the median. Cool. I hope that is clear. And therefore, we can also say that a median of a triangle divides it into two triangles equal area. So this area and this area would be equal because the triangle, the median divides it exactly into two parts. Okay, I hope that is understood. Next up, we have Heron's formula. If we are given a side, if a triangle, let's say I have a triangle. Um, I have a triangle A, B, and C. So therefore, for this type of triangle, we have the side is equal to the side opposite, the side that is to the opposite of the vertex A, that is denoted by small a. Similarly, the side opposite to the vertex B is denoted by small b. and side opposite to the vertex C is denoted by small c. So you can see that. So therefore, A, sorry, we can say that uh, small a, small a is equal to BC, small b is equal to AC, and small c is equal to AB. Okay. Now, what we need to find is first we'll find the semi-perimeter, which is half of the perimeter for the triangle. Now we know that we have these sides B, and C. So therefore, the perimeter would be A plus B plus C. But to apply Heron's formula, we need to find the semi-perimeter of the triangle, that is half of the perimeter. So half A plus B plus C by 2. Okay? Firstly, we'll find this. Let's say it is equation 1. After finding out the semi-perimeter, we need to apply the Heron's formula to find out the area of the triangle, that is given as the area is given as A is equal to under root S, S minus A, S minus B, S minus C. It, it seems to be a bigger formula, but that is not the case. For as soon as you find the as soon as you get the semi-perimeter that is smallest, you can just put in the values and quickly you can find the area. I hope that is clear. So this is the Heron formula. Hmm. Moving further, we can similarly use the Heron formula to find the area of an equilateral triangle with A side units. You are given in the proof. These are the This is the direct result for the equilateral triangle using Heron's formula. I hope that is clear. Next up, we have Brahmagupta's formula for the area of cyclic boson. I suggest you to read this formula and like you just get the theory part done from the textbook. I'll quickly just write the formula, that is area of boson is equal to S. It is similar to the Heron formula, that is under root S minus A, S minus B, S minus C, S minus D, product of all the four brackets. And S is the semi-perimeter, that is half of A plus B plus C plus D. Cool. Let's get to the next part. Again, we have the generalized form for, right. So basically, Brahmagupta's formula generalizes the Heron's formula. You can see that here in as we have triangles, so we don't have the four sides since D becomes 0. So if D becomes 0 in this case, so we get this formula, that is the Heron's formula. I hope that is done. Next up, we have squaring of rectangle. You can do this method from the textbook itself. I am leaving it for the self-study part. I hope you can do this, and it is quite simple. So just read it once from the textbook, and we'll get to the next point, that is area of circle. So area of circle has a direct formula. Again, it says on the basis of it depends on the pi, the value of pi. So the area is pi r square. I hope that is clear. If we just substitute the value of d, that is diameter, is equal to 2r. 2r is equal to d by 2. So therefore pi d by 2 whole square, that becomes pi d square by 4. This is also the formula for area of circle. To derive it, you can refer the textbook and also some internet sources, but that is okay. We just need to know the formula. Okay, I hope that is clear. You can also see over here that the area of circle is half into circumference into radius. That becomes pi r square. Okay, cool. Next up, uh, Similarly, we can use this formula for area of a regular polygon also, that is half into perimeter of polygon into the radius. If we circumscribe a circle inside the polygon. Area of sector of a circle. So basically, this is a sector, you can say that sector that is formed by an arc and joining the center of the circle. So using symmetry for a semicircle, area becomes 1/2 of the area of semicircle becomes half of the area of the circle, that is half pi r square. For quarter, it becomes 1/4. Similarly, as we saw in the case of perimeter. So that is not a problem. So generalized formula to find the area of a sector of a circle is pi r square into theta upon 360 degrees. Theta degrees upon 360 degrees. So we'll get a fraction. Okay. I hope that is clear. We know the definition of segment. Still, we'll relate once. A segment of a circle is a region bounded by an arc of the circle and the chord joining the endpoint of the arc. Next up, we have exercise, and we are done with this chapter. We'll just quickly summarize what we have learned in today's video and this chapter. Firstly, we saw that the value of pi is constant, that is the circumference to diameter ratio for all the circles, and it is approximately 22.7 or 3.14. Then, then the circumference of circle is given as c is equal to 2 pi r, where r is the radius of circle. Arc length is given as 2 pi r into theta degree upon 360 degree. Then area of triangle is given as half into base into height. Then the Heron formula is given as under root s minus a, s minus b, s minus c, where s is the semiperimeter of the triangle, that is half a plus b plus c. Then area of circle is given as pi r square. Then we saw that pi is an irrational number also, irrational number. Then we saw the area of sector, that is pi r square into theta upon 360 degrees, the similar to the uh, length of a circle. Then we saw the Brahmagupta formula for the area of cyclic quadrilateral. Just we need to add these also into the Heron formula to we get this formula. I hope this chapter is understood and you have understood all the concepts. I suggest you to practice the exercises, go to the solved examples, and read the same ones just for your reference from the chapter. Uh, from my side, this chapter is done. We will meet in the next video. Thank you so much for watching this video. Take care. Have a good day. Bye.
वीडियोस बनाने हैं फिल्मोरा है ना।